All right, everyone, welcome. So we're going to go through basically Azure Container Service and using CI/CD tooling like Jenkins. So first up, we're going to look at Azure Container Service, which is basically an automated way for you to deploy Docker orchestration environments in Azure. Currently, we have two orchestrators that you can choose from. You can choose Docker Swarm, or you can use Mesosphere DCOS. We do have others coming, which will include Windows-based container deployment. So at the moment, these are just Linux deployments with these options of orchestrators, but more to come. And they're fully open source stack end to end. So you can deploy any standard CI/CD tooling that you might be using. We're going to look at Jenkins, which is pretty popular, but you can use any other CI/CD tooling to plug in. So about me, I am an Azure technical specialist. I look just after open source software on Azure, and I look after Australia and New Zealand. I'm over in New Zealand at least once a quarter, so definitely sing out if you need assistance in anything open source on Azure. I only joined about 4 or 5 months ago from Red Hat, where I was looking after, mostly focused on their OpenShift product offering, which is based on Docker and Kubernetes. And then definitely an interest area of mine is Docker containers and surrounding ecosystems. Run a couple of meetups in Melbourne, run the Kubernetes meetup and the Ansible meetup. And I also love Raspberry Pis and doing projects with Raspberry Pis at home. So I've got amongst other things, automated sprinkler system that I control with an app on my phone. And my favorite one, which gets a bit of a hiding from me and my son, is my RetroPie arcade. Speaking of Raspberry Pis, obviously fill out the Ignite surveys, but I have a little survey of my own, keen to understand more about what people want to do with open source software on Azure in New Zealand specifically. So the open source team have a couple of pies and some swag to give away if you fill out the survey. So let's first have a look at what Azure Container Service is at a high level. So it's basically you've got virtual machines, infrastructure, so we're deploying, I think Ubuntu 16.04 LTS as the virtual machine. We're laying down the virtual machines, the virtual networks, scale sets, load balancers, the whole infrastructure piece. Then we're basically bootstrapping all those virtual machines for you, installing the required packages, services like Docker, and then we're installing the orchestration platform on top. Effectively, based on your inputs, we're building a customized ARM template for the inputs that you're providing us, and then we're installing that infrastructure and getting it all bootstrapped and ready to go. And then once that's deployed, you are ready to go and basically bring your existing Docker applications and run them on the cluster, or you can stand up tooling like Jenkins, which we'll have a look at, and build containers as well on the platform. So let's jump into the first part of the demo. So we're going to build a Docker Swarm cluster live, and Demo God's appeasing will deploy an application, expose that to the internet. It's the standard Docker example voting application, and in theory, I'll get some audience participation to vote. And then we'll also have a look at a Mesosphere cluster that I've already spun up, and we'll have a look at that for Jenkins. So in the Azure portal, let's go into container services or container service. So I've got a few existing services here. So I'll create a new one. Start off So at the moment they're Linux based, so you'll need to put in a SSH key. Let's call this Ignite Demo, deploy it to Melbourne. And this is where we get our choice of either Mesosphere, DCOS, or Swarm at the moment. So this one we're going to deploy Docker Swarm. And we'll deploy a couple of agents, so you can choose how many agents. Agents are where you're going to run your Docker workloads. Masters are the orchestration engine. So if you want a HA deployment, if you're doing dev, just do 1. If you want to do a production deployment, do 3 or 5, and then we're automating the process of creating that high availability for you with a combination of availability sets, load balancers, and also configuring the actual orchestration software itself. So we can choose the size of our VMs. I'm going to choose the D series, as they've got local SSD, and the V2s are basically the same as V1s, but they've got faster processors. I'm pretty sure they're similar. They're not too much more in price for a decent improvement in performance. Ignite as a demo. All right, and that's it. So it's pretty simple to start that up. Just to highlight the complexity of what is actually going on behind the scenes if you wanted to manually deploy these environments. This is kind of the basic infrastructure that's being deployed in terms of virtual machines, scale sets, load balancers, public IPs, storage accounts, etc. If we have a look at the actual ARM JSON file that was created to deploy this environment, give you a better idea of the size. So this environment's around 1,200 lines of JSON to create that automatically. So we're just automating that all for you. You just take your inputs in the portal, and we take all the hard work away from you. We work really closely with Docker and also Mesosphere and other orchestrator providers going forward to do joint engineering on Azure and also on the orchestration engines to ensure that it works every time, it's seamless, it's well integrated. So while that cooks, we'll switch back and have a look at some Docker kind of 101 stuff. So to get a gauge of the crowd, I assume everyone's heard about Docker. So who has done Docker Run? Show of hands. Good number. Who's done Docker Build? A few less, but still good. All right, cool. So I'm going to go through basically kind of Docker basics, just so everyone's on the same page. It's been around, in the Linux open source world where I live for quite a while, and only recently introduced in Windows Server 2016. So we'll go through that. So a container is basically an application. So you've got your application code and any dependencies that you declare. So if you have a Java application and you need Java runtime to run that, and we're basically bundling that together, and they are running on the host kernel. They share the same kernel. So by packaging those dependencies together, we avoid that it ran in dev, ran on my laptop, ran in test, because a lot of the problems when you're pushing code between environments is there's a disjoint between the version of ASP.NET or the version of Java that was used in the test environment, and a slightly different version in production, and there's a little bit of anomalies around stuff working. So what Docker or containers gives us is the ability to package that as an atomic unit. So we've got pretty good guarantees that it's going to work in all the environments. Next slide. All right. So they basically differ from virtual machines in the fact that they're sharing the host kernel. Each container shares the same operating system, it shares the same resources, and compared to a virtual machine where it'll get its own operating system if you're running them discrete services in separate virtual machines. So they're a lot lighter weight because we don't have the full operating system. So good for provisioning. Let's go back. Good for provisioning, so getting your application between servers and environments, but most importantly in kind of the web scale apps, it's really quick startup time. So I think the Windows container images for, for Nano, you're looking at kind of 2 gig or less, and then 8 gig for a standard Windows image. If you're looking at the Linux world, base images can be as small as like 50 meg or lower. So you can really start those processes up quickly, which is kind of effectively what a container is. It's instead of starting a whole operating system and then starting your application, you're effectively just starting another copy of a process in the operating system, but then we're providing isolation around that process, which we'll touch on in a couple of slides. So can be confusing when you're getting into Docker. There's new kind of vernacular. There's like images and registries and containers and files, and they all have slightly different purposes to play. So 3 kind of fundamental concepts are the Docker file, Docker image, and a Docker container. So a Docker file is a definition file which defines how to build a container. It usually references a source container image. So in the Linux world, you might say, build from Ubuntu 14.04, and then you tell it what packages to install, where to get its code from, and what command to execute when you start the container. When you run a Docker build against the Docker file, Docker build takes the file, executes the commands, and then it outputs a Docker image, which in the Linux world is effectively like a tarball or a zip file. So it just builds the app, zips it up, wraps it in a Docker as a Docker image, and then you push the image to a registry. So most popular public registry is Docker Hub, but you can also run private registries within your own premises, and you have a local registry on your laptop, on your server where you're building as well. And finally, an actual definition of a container is a running instance of a Docker image. So I've taken a file, a definition, we've built an image from that definition, and then when we run the image, that is called a container. And then once it's running, we can use commands like docker ps, etc. on running containers. So when we look at how we provide isolation in containers, in the Linux world, there is 3 kind of main isolation technologies that we use. The first is control groups or C groups. So this is code originally contributed a while ago from Google to the Linux kernel. And this basically provides resource control. So this says this container can only use 128 meg of RAM. It can only use 2 CPUs. It provides that constraint at the kernel level. So it can't use any more resources and contend with other applications on the system. Then we have namespaces. So namespaces is basically giving the process a view of the operating system, its own world view. So it can see mounted folders, it can see running processes only within its little namespace. It can't see anything else running on the host. So as far as the container is concerned, it's got a whole operating system to itself, and it can't see anything else running on the OS. Then we have layered capabilities. So when you build a Docker file, it actually builds up layers, which is really neat when you start making changes to your applications. You're really just pushing the delta in the images to your running containers. So allows you to really quickly update running containers with new code. So really useful in continuous integration, continuous deployment scenarios. So basically what Docker has done, all these technologies existed before Docker came on the scene, 2 to 3 years ago. We had control groups, we had namespaces, containers had been around in Linux in various forms and also Unix. But what Docker did is make it really simple for developers to build applications and administrators to administrate environments. Because previously to do all these functionality with a process was pretty complicated. And now you just have to do like a Docker build, Docker run, and then Docker controls all that for you, takes away all that complexity. So in the Windows world, we have also the same concepts. So we have control groups, which are job objects. We have the same concept of namespaces, and we have the same concept of the layering capabilities. They're just executed differently. A lot of these services were already in Windows, but we just didn't make them. You didn't externalize those APIs to end users. So what we've done now, working with Docker, is basically make those services more consumable for users and put the Docker engine in front of it. So Docker can now control those components in the operating system for you. So key point to make is the one shared aspect of containers is the kernel of the operating system they're running on, so they don't have their own kernel, which means that Linux containers can only run on Linux kernels, and Windows containers can only run on Windows kernels. But we're obviously investing a lot in Docker to make Windows containers real and usable. And what it'll mean for developers and administrators is you need to run the containers separately on their required operating system, but you're going to be able to use the same tooling to do it, same Docker tooling, same Jenkins, Visual Studio, Team Services, etc. And you're going to have flexibility around where you can take those containers. So you can run those containers on physical hardware, virtual hardware, you can run them on Azure, you can run them on any other cloud. So it's going to provide you the same tool chain and the same portability whether you're using Linux apps or Windows apps. Cool. So just talked about that. Yeah. So basically, as a developer or an admin, I've got the Docker client at the top, so that's Docker exe, and then I'm just going to execute the same Docker run, Docker build, etc. And the Docker daemon, whether it's on Windows or Linux, not Windows, is going to execute that functionality in the operating system of choice. So in terms of where you can run Docker in Azure, there's kind of 4 main ways. The first way is you can run up a virtual machine and you can install Docker on it and just run Docker containers on a single host. You can also leverage virtual machine extensions to automate that for you. So you can go to the portal and choose extensions, and then Azure will basically automate the installation of the Docker engine, and it can also bring up a container for you. So you don't have to do that configuration on the operating system. Got a number of third-party vendors who have full-blown platform as a service offerings that are built on top of Docker. So likes of OpenShift from Red Hat, Cloud Foundry from Pivotal and Deis. we've got the Azure Container Service, which I'm going through. So the point of Azure Container Service is to automate these platforms for you, but it will always be like a fully open source stack. So it's the exact same stack you can deploy on-premise or in another cloud. And if you want, more premium features from Docker or from Mesosphere, then you would buy their third-party offering. So from Docker, it's Docker Data Center, or they're working on Docker for Azure, which is a specific offering for them, which will install Docker Data Center onto Azure. And then we've got another number of other marketplace offerings. So we've got other partners in the marketplace like CoreOS, Rancher, so a lot of other popular operating systems and platforms in the Docker ecosystem. So let's go back and hopefully we'll have environment. Let's see how that's going. Okay, cool. So we've got an environment. Let's go in, what was it, Ignite Demo. So let's go in there. We are going to SSH into the master so that we can bring up a application. So grab this bad boy. Exit, clear. All right, so I'm now SSH'd in. Let's go and grab our voting app. So the Docker voting app is forked from the Docker repository on GitHub. It's the standard kind of app they do to demo the capabilities of Swarm. So we just want to grab our repository URL. We want to do a git clone of that bad boy. And we go on there. And the beauty of Swarm or Docker Compose specifically is we just go into the directory and we do a Docker Compose up. And before we do that, actually, I'm going to run screen. So screen, for those who are not familiar with Linux and SSH, when you SSH and you kill your session, you kill any processes that are running in it. So you can use a service called Screen, or another popular one is called Tmux, and they basically ensure that whatever you're executing in the terminal, if I get disconnected or something, it'll keep running. All right. Yes. Yep. I'm going to have a look at that now while that's building. So that is going to build our application. That'll take a little bit of time. So while we do that, let's first go and have a look at a Docker file. So, so this is an example of a Docker file. To start off with, we have the from. So this is the based image. We're getting it from the Microsoft repository on Docker Hub. We're getting the .NET image, and we're specifying a tag. So you can use tags to version your code, You can do version numbers or words, production tests, etc. Then we're telling it, where we want to work from, what files or directories we want to add, and then what do we need to run. So when you do the run, you might install some packages, you might pull some code from somewhere, and then finally you've got your execution command down the bottom. So when I do a Docker run of that container, it's going to run that command I specify to start up my process. So then we've also got the compose file. So the compose file is a YAML file. And when you're running a Docker container by itself, you just use a Docker run. But if you want to run like a N-tier application, you've got a front-end application, you've got a worker, and then you've got a database app. You can use a Docker Compose YAML file, or in Mesosphere they use a JSON definition, and same in Kubernetes, you can use a JSON or YAML definition of your app. And basically here we're defining different containers within our whole application. So we can then define our application as one unit, and when we do a Docker Compose, it's going to bring up all the services. We're going to define, what volumes we're going to mount. We define what ports the application is listening on inside the container, and what port it should attach to on the host or on the virtual network if we've got a software-defined or overlay network, which is what we use in Docker Swarm or Mesosphere. So that is that. Let's see. All right, still building. That's cool. Let's change gears and we'll have a look at a Mesosphere cluster. We'll have a look at some Jenkins stuff while that continues to build. So again, I'm going to find the public IP address of my master. Grab the DNS name here. We'll open up a new terminal. By the way, I'm using Bash on Ubuntu, so that's using native Ubuntu user mode, translating Linux syscalls to NT kernel. So pretty useful from a developer point of view. You don't need to use PuTTY, and you can use all native kind of open source tooling that you might be, prefer to use. So for this one, we are going to use an SSH tunnel to basically tunnel a port on my local host through to the remote host, so that I can see my applications. So tip for anyone using Ubuntu on Bash. So this first point is saying on my local IP address, which is looped back on port 80, forward that to localhost on the remote to port 80. So usually you don't need to put the loopback IP in there, but the Bash on Ubuntu is still in beta, and one of the bugs is that it tries to do IPv6 stack for some reason and bugs out. So by specifying an IP4 address, you force it to use IPv4 and fixes up. I know the bug's been fixed in a later Insider, I think the fast ring on the Windows Insider program. All right. So let's change that. We'll specify our SSH key. Oh, I have to escalate my privileges. because it's port 80. All right, so now we're on the master. We've forwarded port 80. What's happening here? Okay, weird. Top of my screen is permanently there for some reason, so let's continue on. All right, so this is what you see when you get a Mesosphere environment. So you get, pretty little portal. It's going to show you what resources you've got in your cluster, shows you all your services, etc. I think I might know why that's not working. So to install Jenkins, all you have to do is come into the services part. I've already deployed one, but I'll show you how you can deploy one. Actually, I don't want to do it from there. Apologies, I want to go to the universe. So you can deploy a service manually. You'll have to bring your definition of the service, but a cool thing to get started quickly on Mesosphere is the universe, which is basically a package management and deployment to deploy onto Mesosphere. So in here, this is how I've installed Jenkins. You just come into the universe here, click install package. I just did a vanilla install. You would probably want to do an advanced installation and set up a actual storage volume on Azure Storage, because my Jenkins is literally running as a container, so any of the configuration I'm writing into Jenkins is just writing within that container. When that container dies, lose all my data, so you have to rebuild it. So good thing, practice to get into for your applications. If they need stateful data, you'd need to mount that outside the container, because once they die, you'll lose any of that data. So let's go back to services, and I might actually just fix up my marathon JSON, which I think is making the deployment fail. So this is the JSON for Marathon, which is similar to the Docker Compose YAML that we saw. So this is their way of how they define it. So JSON format, similar functionality, you're defining the resources it can use. We're defining the containers, what port the container's listening on, what port to mount onto the host. Just edit this because I think I screwed up my build. All right. Let's get rid of this one. So we load up Jenkins. I've already got a job configured here. In order to basically take your application and build it, you'll need a couple of things. So in here, I've got a repo of just a sample Hello World app. You're going to need a Docker file. So I'm just using the sample app. It's building from Ubuntu. Here it's installing these packages, PHP, etc. We are running a couple of commands to change permissions of directories, and we're telling it, what to start up when we start the app. You're also going to need the Marathon JSON, and then also the code. that you've got. So when we go back into here, you're going to need a couple of plugins installed. So you go into Manage Jenkins, you go into Manage Plugins, then you'll want to go to Available and search for these plugins to install. Because I've already got them installed, we'll go in here. The first plugin you'll need is the CloudBees Docker Build and Publish plugin. And this basically just takes your Docker file on GitHub, executes the build, and pushes it to a registry, which you define. The second one you'll need is the Marathon Deployment plugin, and that allows us to deploy that JSON template into our DCOS environment. This one, by the way, if you deploy Jenkins from the DCOS universe, it'll already have the Marathon plugin installed by default. If you stand up your own Jenkins server, so say you stand up Jenkins from the Azure Marketplace as a separate VM, you'll have to install the plugin manually, and I don't think it is actually available in the Jenkins package universe, so you'll have to download the package manually and upload it and add it, which you do in the Advanced tab here. So upload plugin. So let's go back to the job. I'll kick off a build while we have a look at the job. Neat thing as well when you deploy Jenkins from the DCOS universe. So Jenkins has a concept of workers, and the worker is what's going to build your application. So the neat thing about deploying it onto DCOS is in here. So it'll actually on demand spin up a new Docker container to execute your build, and then it'll build it and then it'll shut it down. So you don't need to have like builder nodes available all the time consuming wasted resources. It just spins it up on demand when it's needed as a Docker container, which is pretty cool on the environment. So that is kicking off. So let's go have a look at how I've configured that. So I've just created a, actually we'll go back here. I've created a freestyle project. That's all I've done. Once you click next, it'll basically take you to this page, which is the configuration. In here, all you need to do, all I've done to get this sample app from Docker going, you have to give it a name. You'll have to tell it you want to use a GitHub account. You point it to the repository on GitHub. If you want to use the GitHub plugin to monitor for when you push a change to GitHub, you'll need to put in credentials. If you are using two-factor authentication on GitHub, you'll need to create an access token and use that as your password, not your normal password, because Jenkins can't do two-factor by itself. Here we can tick, it'll use the GitHub plugin to monitor for changes, so it'll rebuild the app if I push a change to GitHub. So that's really when you're doing that, continuous integration. You push a change into your master trunk, and it's triggering off a build automatically. Then I have added a build step. Oh, it's probably not going to show me that. So I've added the Docker build and publish step to my build, which I'll need that CloudBees Docker plugin to do. And here I'm just going to specify my Docker Hub registry. For my application, you can put in a tag, and then you'll need to give it credentials for Docker Hub to be able to push that new image to the registry. Post-build action, again, I'm going to choose, select here, Marathon Deployment, and then it'll bring up these options here. Because Jenkins is running within my Mesosphere cluster, I can use the local Mesosphere DNS, which will resolve for me. So what I haven't set up is, I haven't made this cluster available to the internet. So everything I'm doing is through a tunnel. If you wanted to point to an external Jenkins server, you obviously put in the actual DNS name of your Jenkins server. But because it's running within the environment, I can use the native DNS resolution. Just give it a name, tell it what image you're going to run, and that's it. So let's go back and have a look. So once Jenkins is building my application, I can go into console output, and this is going through. Let's go right up top. So it's grabbing all my source code. It's pulling, we had that Ubuntu trusted. That's where I said from this base image. So it's pulling that image. It's pulling all the layers of that image if it didn't have them. It's installing all the packages I told it to install, et cetera, et cetera. So it's going through that Docker build process there. Hopefully it should be finished shortly. All right, and then finally it's going to do that marathon deployment. So it's going to take that JSON file that was in my GitHub repo as well. It's going to take that, go to Marathon and say, hey, you need to deploy this image that I've just pushed in this configuration with these ports, etc. And we are deploying. See if we get lucky. There we go. So there we have, it's basically taken my Docker file, it's done my full build, it's pushed it to the registry, and then that's available. So note here, this is working through my SSH tunnel. So it's forwarding port 80 from local to the cluster over SSH. If you want to externalize it, you'll need to do some Azure load balancing and stuff, which we'll go through with the Swarm demo. So that's the end of Mesosphere. So changing back gears, let's go back to the Docker Swarm demo. And this is expected behavior. I don't know why it does this. But basically when you take that example voting app and you do a Docker compose up for the first time, I can't get it to run for some reason. But if you run it again, we'll just do a Docker compose down to ensure everything's down. But for whatever reason, if I do a Docker compose up, second time works like a charm. Sorry? Yeah, I think maybe the containers come up in the wrong order because, yeah. So when you do it a second time, all the images are in my local registry. It brings them up how it should. And green is good, so it's connected to the database now, which is good stuff. That means we should be good to go. But we still only have an application that is within the cluster. What is with this screen? All right, let's soldier on. So we'll go to the resource group of our Docker Swarm cluster and say ignite demo. And we want our master load balancer. So you're going to have to do a couple of things. So my application, by default, that example voting app, there's two components. There's a voting app and then there's a results app. The voting app listens on port 5000. The results app listens on 5001. So first, in order to create a load balancing rule, we need to create a probe. So let's call it voting app. Killing me, computer. So that's creating the probe. If you're doing things properly, you should probably create a probe per port, but for the sake of the demo, I'll just create one and use them on both load balancing rules. So we're just going to have to wait for that to update before we can add the rules. So it shouldn't take too long. All right, so there we have our rule created. It still locks the creation of the rules and probes until that's fully finished. So you could obviously do this via command line. So we just released a new cross-platform command line, which is now in Python. So you now use AZ is the command line that you use. And we're now building that off JSON Swagger documentation. So one of the issues we had with the cross-platform CLI before is that it wasn't in cadence with PowerShell and new services coming on and new APIs. So we've fixed that and should be pretty fresh pretty much all the time. So let's do voting app. So I'm going to listen on port 80, so you don't need to chuck a port in front of the URL, but we're going to redirect that to 5,000 at the back end. And while that creates, the other thing that we need to do is we need to apply a network security group to the subnet. So by default, I think on the Mesosphere cluster we do create a security group, but still not exposed to the internet. On the Swarm cluster we don't by default attach a security group to the subnet. So we want to get the master subnet and we want to choose network security group. Edit that. And we're going to add one that I have already prepared. So network security group is just an ACL, firewall access control list. So by default, if you don't have a security group or an ACL, we're just going to deny everything inbound. And all I've done here is say anything coming in on port 5000 or 5001, let it through. So that's what we're doing there. We'll go back to the load balancer and we'll add in the rule for the results app. And that is on 5001. We'll redirect that to the same port in the cluster. So now we have a externalized app that is load balanced, but it's got a long URL. So what I'm going to do is go into Azure DNS. So this is a reasonably new service where you can host your DNS records in Azure. I'll go in here. We will create a new record set. We're going to create a CNAME record. I'm going to redirect it to here. Let's put TTL. And we're going to do MS. Well, let's just do ignite nz.onazure.io. So, just provided I haven't shafted my demo, if you get out your phones and go to ignite nz .onazure.io, oh dear. Oh no, I didn't do NZ. That's better. So there we go. So there's an example voting app. Tough decision, but personally prefer an Epic IPA. So if we go in there and we go to port 5001, we'll start seeing the results update. So it's using I think it's a 4-tier app. It's got a front end, it's got a Redis cache behind that. So currently it's only running one container, but because it's got a Redis cache, it can handle a fair bit of hits. And then it's got I think a .NET Core worker app, which doesn't have to do much work. And then there's also, I think, a Postgres database. So it's a good example of using containers in a microservices architecture. So you can have a polyglot, multiple language application architecture and define that, with your Docker Compose or your Marathon JSON file. I think they're running. Sorry? The front end version? There's just one container, so I'm not load balancing, if that's the question. Yeah. So you can, what is not set up on the Swarm cluster, so we're just using standard Docker daemon on the Swarm cluster. We're not, even though it's using Docker 1.12, which has Swarm mode, which is something a little bit different from Docker. We don't enable Swarm mode, and Swarm mode will do like dynamic load balancing, service discovery, and stuff like that. If you want to do a similar thing with load balancing, service discovery in Mesosphere, you'd use Marathon load balance or something which you can install from the universe in the DCOS cluster. So this is just a basic, single point of failure app, but good example of what you can do. So let's go back here. We went back to the demo. All right, so we're almost up. So I'll just smash through these slides and I'll let you get off to the party. So just a kind of quick update on what we're doing around open source in general. So we've got a lot of, making a lot of changes, well, big transformation in how Microsoft's approaching open source, which is, really started to hit its stride in the past couple of years since Such has come aboard. So we've got, SQL Server is going to be available on Linux next year. Key point being it's SQL Server core, not the surrounding services, but it starts up in like seconds, like under 10 seconds. So if you're familiar with how long it takes to install and start SQL Server on Windows, bit of a change. So it enables you to do like take your existing SQL code or apps that use SQL and do kind of scale out dynamic workloads really well. Marko Sinovic demoed SQL running on Ubuntu, in Docker, on Azure, so cool little use case. We've got the Windows subsystem for Linux, which I was using, so allows you to do native Linux commands. So great if your devs are familiar with Linux or open source and you want to use open source tooling natively on Windows, but you also want to read email and collaborate with employees on the same platform, kind of useful. We've also got the majority of images in the marketplace are all Linux and open source based, and we've got 1 in 3 VMs on Azure are currently Linux, and VMs being deployed, the majority is Linux. So you'll see that stat kind of grow to 1 in 2 and so on and so forth. We've had key partnerships recently with Red Hat, so we provide the best support of any public cloud for Red Hat workloads. So we have Red Hat support engineers sit in Redmond side by side with Azure support engineers, fully integrated ticketing systems. We're also doing joint engineering work, things like enabling .NET for Red Hat Enterprise Linux, enabling OpenShift on Azure. So we have better support. We're also like joined at the hip in terms of making our products work really great together. And we've got some key employees. More interesting to me is Brendan Burns joined from Google about 6 months ago. So he's the co-founder of Kubernetes, which is another very popular container orchestration platform. So I'd expect to see more happen around there in future. And the next one is like how we're demonstrating the change of Microsoft. So when I started 5 months ago, I think it was like 600 million lines of code committed by Microsoft engineers on GitHub. It's already over 700 million lines of code. So big change in how we go about creating our own software and our own platforms. To put that into context, Linux itself is 25 million lines of code. So we're putting significant investment. There's a lot of products being come out as open source first. So on Azure, we're enabling Linux workloads. So this is things like Linux integration services, Hyper-V drivers, making Linux native in Azure App Service. So web apps can now run PHP and Java on top of Linux, or you can choose to run it on top of IIS is the standard way you can do it. We're providing integrated solutions, so Azure Container Service is a really great example of one. We're taking best of breed or the most popular open source projects, and we're making them, we're just taking all the complexity out of setting them up, because for anyone who's tried to set up like a Swarm cluster or a Mesosphere cluster from scratch, it's a lot of work and it's quite complex. And the same applies for other things like installing Hadoop clusters, so we've got HD Insight for that. Just make it really easy to consume these, they're really good technologies and projects once they're installed and configured, but sometimes they can be pretty complex to set up. We're also releasing key products into the open source ecosystem, so things like .NET Core, PowerShell most recently. So basically letting admins and devs use Azure or Microsoft, regardless of whether they're using Mac or Linux desktops, and we're participating in communities. In terms of running Linux on Azure, you can get it from the marketplace. You can bring your own SOE, or you can use Docker. We support all major Linux distributions, so Red Hat, Ubuntu, CentOS, Oracle Linux, SUSE Linux. We also support a lot of container native operating systems with vendors, so CoreOS, Rancher, things like that. That's it. So key takeaways. So we looked at Azure Container Service. So currently you can deploy either Docker Swarm cluster or a Mesosphere DCOS. Windows to come. Currently no ETA on when that's going to be available, but since 2016 is now GA that provides the fundamental capabilities to do that. Wouldn't expect that's too far away on the roadmap. And there'll be other open source orchestration engines to come as a choice as well. So you can easily plug in your favorite CI/CD toolchain. It might be Visual Studio, it might be Jenkins, it might be Atlassian, etc. Easy to plug in because it's a full end-to-end open source stack. We're not doing any fancy customization proprietary stuff there. So call to action, would love to get your feedback on the survey form for the open source. Enter to win a Raspberry Pi and some free swag on that URL, tinyurl.com/nzoss. Try Azure out for free. You can get a free trial if you haven't tried it out yet. And also there are courses on Microsoft Virtual Academy for heaps of stuff around open source. But there's also, I think there's like 3 courses for Azure Container Service specifically. And there's one really good one, which that bit.ly URL will take you directly to, and that will take you from go to woe to go, deploying a DCOS cluster, doing everything we looked at, stand up Jenkins, stand up an application. It'll also go one step further and you look at, I think, Marathon LB, so making, deploying service discovery and dynamic load balancing, etc. Remember to do your surveys, very important. We really appreciate the feedback and want to improve, the conference overall and sessions. And that's me. I won't stand between you guys and a beer. If you want to come and ask questions, feel free. I've got some stickers here. I've got like the Docker Azure command line and some stuff similar to what I'm wearing. Yeah, so thanks very much, guys.